Good evening, everybody. This is Dr. Paul here. Today, I am going to talk about a simulation model that is free air temperature enrichment system. This is a very important simulation model for crop research that has been globally used. Apart from the free air temperature enrichment system or free air temperature enrichment technologies, I am going to talk about free air CO2 enrichment technologies, how to integrate both temperature and CO2 for enrichment of CO2 and temperature in open atmosphere. As I have told my earlier three presentations, those technologies, those simulation models are used for crop research, for development of varieties. So in open atmosphere, how do we enrich the temperature in a very precise manner? That is the main objective. When I talk about the enrichment of air temperature in open atmosphere, it is very difficult to enrich the temperature and maintain the uniformity of temperature in a given area. So in free air temperature enrichment, what we do basically, there is a defined area. It might be 2 meter, 3 meter, 4 meter, 5 meter or 6 meter. It can be a square structure, it can be a circular structure, or it can be hexagonal structure. So what we essentially want to do it, we want to build the structure first. First of all, you have to have the simulation structure that is built based on the application. As I have told that any crop research, the kind of structure to be developed, it is purely based on kind of crops to be grown inside the chamber. Based on the height, we need to decide the size and dimension and height of the structure. Now, typical FET research, you can go maximum up to 11 or 12 meter structure, individual structure. Height you can have up to 10 or 15 feet. And when I talk about the increment of temperature inside the ring, your placement of heaters to be placed such a way that temperature uniformity to be maintained throughout the area where the crops will be grown. Now, how do you mount those kind of heater? What kind of heaters will be selected? That is also very important. Generally, in earlier times, you can increase the air temperature by purging hot air. But the problem when you are using hot air blowing system, it can increase the temperature, air temperature of ambient plus 2 to 3 degree temperature, but there will be a air turbulence. Disturbances of air can be observed. And climate change research, this is not number one, is recommended. And second part, the hot air blowing system or heaters, once we are using it, there is a chance of creating gradient atmosphere. It is going to create a gradient profile. It is ambient plus 1 degree, 2 degree, 3 degree in different temperature zone. There will be a gradient atmosphere that is created inside the defined area. So in order to avoid that, what we are using it, we are using ceramic infrared heater. Ceramic infrared heaters are electromagnetic radiation that is coming 385 nanometer to 1 millimeter wavelength. There is a ceramic enclosure and coils are mounted inside that. It has got different capacity, either it is 500 watt or 1000 watt, or you can go 1500 watt or 2000 watt in one ceramic heater. You can have different modules, a set of ceramic heater that can be fitted together. So once you switch on this ceramic heater, which is having the coil, infrared magnetic wave is coming out, and there is a reflector. This is a SS reflector. On that reflector, it emits electromagnetic wave, and that hits off the air. So it indirectly or directly increases the air temperature. So then whatever crops are growing inside that particular area, so it can heat up that particular area with 2 to 3 or 4 degree temperature based on what is the level what we are deciding. What kind of temperature we need it, either it is ambient plus 2 degree or 3 degree or 4 degree, we can calculate number of heaters to be mounted. Those heaters can be mounted either horizontally or vertically. So you can mount those heaters and give proper power supply and controller, and it is going to work whatever specific temperature we need it. Now typically a 7 meter or 8 meter radius, if we want to enrich the air temperature to 3 to 4 degree centigrade, there must be gang of heaters that can be fitted from the side and also from the center, and if possible from the top mounting. Through a cable tie you can put those heaters. It is very important to note the kind of cable tie what you are using or kind of pipes you are using. It should minimize the shade effect. So in that way that entire area can be encircled with different capacity of heaters, so that to achieve that particular temperature. Now coming back, how do you control that particular area air temperature? So obviously there will be a reference temperature, that is the PT100 sensor that we will be putting outside. So that is going to, now if you are setting in the computer, this is a fully again automatic control system. So it is very important to note that when you set your parameter that you want to have ambient plus 2 or 3 degree centigrade temperature to be maintained, so there will be two temperature sensor, one is for ambient and one is for the elevated fatty, that is free air temperature enrichment system. So always it is going to measure the existing, that is the ambient temperature, and it is always try to see 2 to 3 degree temperature increment. So heater on off will be based on what is the existing level of temperature is been maintained inside the ring. If it is lower, heater will be on based on the set point. Once it achieves the particular temperature, your heater will be stopped. So in this logic control, you are operating all those heaters. This is for the heating purpose, you develop the system. Now for experiment purpose, what you need to do essentially, if you are working on free air temperature enrichment system, one should be ambient ring where you are not putting any kind of heaters, it will be a dummy structure, and another is ambient plus 2 degree. You can make one more structure ambient plus 4 degrees, similar kind of structure and similar kind of heater management one can make it, so that you can have total 3 rings. One is for ambient, one is for ambient plus 2 degree and another for ambient plus 4 degree or 5 degree, so that when you are growing plants, when you are setting up the experimental plot, you can have 3 different variants and you can study the impact of plants starting from germination to flowering to seedling to maturity. Those kind of stages and different observation one can do it for research purpose. Now the question is, apart from temperature, you can have online real-time monitoring of humidity, you can have soil moisture, soil temperature, PAR also. So those are the parameters one can study throughout the time. Apart from that, online CO2 also, because when you are increasing the temperature little higher level, CO2 level also, whatever changes are coming, that can also be monitored if you want to put a CO2 monitoring system in the ring. So those kind of, and this is the way you can build the system, and also the complete data monitoring, data logging, control system can be built up in a PLC based system, and can be data logging can be done in a computer throughout the time. It is a purely manless operation. Regarding the controlling action, I have told many times the logic control will remain same irrespective of either for OTC technology, phase technology, fade technology. Almost the concept remains same for data logging, hardware, everything that is remaining the same. It is the same basic fundamental principle. Whatever sensor you are mounting, you take the output option and one need to select what kind of output option you have in each sensor, put into the data logging, then whatever parameter you want to control it, you give the logic control for the controlling, and also whatever things you want to do the data logging, that logic control to be developed in the PLC, the controlling the system, and that way one can develop the system. This is one part. Now coming back, as I have told you in my previous presentation, that only temperature, only free air temperature enrichment system is not going to work for your application, because you want to, along with that, if you want to study the impact of CO2, how CO2 level is impacting in different temperature level, that probably for that purpose what you need to do it, you need to have the incorporation of CO2 releasing option for each ring. For that purpose, you need to configure this system. One is for ambient, it remains same irrespective of fade or phase system. One for a one level of temperature, ambient plus 2 degree. Another is for ambient plus 3 to 4 degree temperature. And one for temperature plus CO2. Maybe you can set a particular temperature, means ambient plus 2 degrees, CO2 level ambient 380 ppm, you can have 500 to 550 ppm one set, and another ambient plus 3 to 4 degrees centigrade and CO2 level 600 to 650 ppm. And if you want to have again independent study of CO2, only the impact of study, you can have a CO2, pure CO2 ring without temperature. You can have two different set point in two rings, you can do it. That way you need to have minimum 6 or 7 rings together for carrying out the whole experiment. Now, in order to simplify the thing, one can also develop a single ring having both temperature and CO2 options facilities for all the rings, so that you can develop 3 or 4 rings as and when required based on your experimental design. Whether if you want to use only the CO2, you can skip the temperature part, and permutation combination can be done in order to design your experiment. So if you really want to have the cost saving for different treatments, you can be very specific and you can design or develop system such a way so that you can have cost cutting. Because for development of face or fat ring, if you incorporate all the things in one ring and do not like to use it, it will be unnecessarily wasting money. So that it is better, if you want to have a ambient ring, you need to have a only dummy structure, only the monitoring facilities. If you want to have the temperature, where you only want to put the temperature related heating system for 2 rings. If you want to have only CO2, there you need to put only the CO2 monitoring and control facilities, where you want to put CO2 plus temperature, then there itself you can put CO2 and temperature monitoring and control facilities. That way one can save money. This is up to individual researcher how they want to configure the system, so we do not have much more say to that. Now the question is, once the system is developed, that can be housed in a control room, your analyzer, your computer, your CO2 releasing system, compressor, CO2 tank, everything can be placed in a particular place, and all piping, tubing can be taken into the field level through a solenoid control action. Everything can be monitored, specifically the CO2 controlling part. Now the question is, how to monitor and control those parameters. This is the structural part done, this is the monitoring part I have explained to you, and I have also explained to you how one can take the wiring instrumentation, where it can be wired or wireless communication system. The choice is left with the individual user, how they want to build up the system, kind of money provision they have, the similar kind of system can be developed. Now coming back, the kind of system what we have developed for various research institute in India, we have developed several FATE system, the free air temperature enrichment system in India. To name a few, we have developed at Nuclear Research Laboratory, the Agricultural Physics Department, that is for IRI, Indian Agricultural Research Institute in Pusha, New Delhi. The FATE system what we have developed for them, we have developed FATE system at NBRI, National Botanical Research Institute. It's a CSI research institute in Lucknow, and we have developed a very complicated system. This is not only temperature. Apart from temperature, we have developed phase system, FATE system, phase plus FATE plus ozone system. It's a like temperature, CO2 and ozone. There are 2 gas component, that is the main focus, plus temperature. So we have developed close to 10 or 11 phase ring for NBRI Lucknow. And we have also developed FATE system for ISBT. It's a CSIR institute at Palampur, Himachal Pradesh. And this is purely infrared heating system, along with the phase and FATE combined system we have developed for them. We have also developed phase system and FATE system for Dr. M.S. Swaminathan Research Foundation in Chennai. So we have used infrared heating system for heating up that particular ring. Those are the few systems what we have developed for various research institute, and those systems are in operation. Today my topic is restricted only to FATE and phase, how you are combining free air temperature enrichment with free air CO2 enrichment. And in my next presentation I am going to talk about how free air ozone enrichment system can be developed, what are the components for ozone enrichment system, and how ozone enrichment system can be integrated with phase free air CO2 enrichment and free air temperature enrichment. That I am going to discuss. Now I want to talk about few things over here for FATE, the kind of temperature monitoring facilities, the PT100 sensors what you are using, it should be very high quality temperature sensor, high quality moisture or humidity, soil moisture, soil temperature, all those sensors, hardware what you are using, it should have good quality so that it can work for longer time, good wiring system or wireless communication system one can provide so that the system is reliable, and a good software so that with a good data backup you should have good Excel PowerPoint presentation for all the data monitoring and control. It should come in an Excel sheet with a 20 with a backup facilities. So we are providing such kind of system for all those institute and we are supporting them. I have nothing more to talk about free air temperature enrichment system, but free air temperature enrichment system along with the phase system has got enormous importance, and this is a good simulation crop varieties. So thank you very much for hearing my small talk on free air temperature enrichment facilities, and this is in continuation my commitment to present 8 lectures on simulation model on climate change research. On World Environment Day, this is the commitment I have made, and I hope this information is going to help the researcher, student or learners, whoever is interested to do it. Once again, thank you very much for hearing my small talk. Bye bye.